TechDaily.ai, your source for technical information. This deep dive is sponsored by Stonefly, your trusted solution provider and advisor in enterprise storage, backup, disaster recovery, hyperconverged in VMware, Hyper-V, Proxmox cluster, AI servers, and public and private cloud. Check out stonefly.com or email your project requirements to sales@stonefly.com. Welcome to the deep dive. Today, we're getting into something absolutely fundamental to how the internet works, the domain name system, or DNS. We're going to explore how this system, which is essential for getting us anywhere online, can actually be twisted and used maliciously.
Right. And it's interesting because some techniques we'll discuss can be used legitimately, but our focus here is really on the dark side, how they're misused in security incidents.
Exactly. And we're kind of basing this discussion on a framework, a way to structure our thinking about this threat landscape.
That's right. It's designed to help incident responders, the people on the front lines, understand the different ways attackers leverage DNS.
And crucially, it helps figure out who can actually do something about it, right? Which part of the whole DNS ecosystem needs to act?
Precisely.
Right.
Because when you're in the middle of an incident, you have to assume malicious intent. That's the starting point.
Okay, so this framework looks at things from a few angles.
Yeah, three main dimensions. There are the actions, what you can do, detect, mitigate, prevent. Then the techniques themselves, the specific methods attackers use.
And the third.
And the stakeholders. These are the different players in the DNS world who actually operate the infrastructure and can potentially step in.
Got it. Actions, techniques, stakeholders. So let's dive into some of those techniques. Domain generation algorithms, DGAs. That sounds pretty technical.
It is a bit. DGAs are, well, they're algorithms malware uses to create huge lists of domain names automatically.
Why would it do that?
It's mainly for command and control. The malware tries connecting to these generated domains, hoping one of them is live and controlled by the attacker.
Ah, so instead of one fixed address that can be blocked?
Exactly. It generates maybe thousands. If you block a few, it just tries the next ones on the list. Makes it much harder to shut down communication.
A constant game of cat and mouse, then. Okay, what about domain name compromise? That sounds more straightforward.
On the surface, yeah. It means someone wrongfully takes control of a domain name that isn't theirs.
Simple concept, but the impact could be huge, I imagine.
Oh, absolutely. Once an attacker controls a domain, they can use its reputation maybe for spam, phishing emails, distributing malware.
Or even setting up their own command and control infrastructure using that legitimate-looking domain.
Yes, or using it for botnets. It gives them a powerful tool. Getting it back can sometimes take time to, verification and such.
Right. Okay, next one. Lame delegations. That's an odd name. What's going on there?
Hey, yeah, it sounds a bit funny. But it's a real issue. It happens when the domain names registered for a site's name servers expire.
The name servers themselves, not the main domain.
Correct. The domains listed in the NS records. If those expire, an attacker can potentially re-register them.
And if they grab those name server domains,
then they control where DNS queries for the original domain get sent. They effectively hijack the resolution process.
Wow, okay. So you could lose control of your traffic even if your main domain registration is perfectly secure. Sneaky.
Very. It highlights the need to keep track of all the domains involved in your DNS setup, not just the primary one.
Makes sense. All right, let's talk about something maybe more familiar. DNS cache poisoning, or DNS spoofing.
Right. This is a classic attack. The idea is to inject bad information, false DNS records, into a DNS resolver's cache.
The resolver being the server your computer asks for directions.
Exactly. So if that resolver's cache gets poisoned with a fake record for, say, your bank's website,
then when I try to go to my bank,
the poison resolver sends you to the attacker's fake site instead. Looks like your bank, but it's there to steal your login details or worse.
Manipulating the map, essentially.
Yeah.
Nasty. What about DNS rebinding? That sounds a bit more complex again.
It is a clever one. It's an attack where a malicious website you visit tries to make your browser talk to devices on your local network.
Wait, how? Isn't that usually blocked?
It usually is, by something called the same origin policy. But DNS rebinding tries to trick the browser. The malicious site quickly changes the IP address associated with its domain name from its real internet address to a private IP address, like 192.168.1.1 or something on your home network.
Ah, so the browser thinks it's still talking to the original website, but it's actually sending requests inside your network.
Precisely. The goal is to bypass that browser security and potentially access, say, your router's admin page or other vulnerable devices on your LAN.
Yikes. Okay, that's a serious potential breach of the local network boundary. Let's switch gears slightly. How can DNS itself be used as a communication channel, like for infiltration or exfiltration?
Yeah, this is fascinating. Attackers can encode data into DNS queries.
Like hiding data in the domain name being looked up.
Exactly, or in different record types. To get data out, exfiltration, a compromised machine sends these specially crafted queries. The attacker needs control over an authoritative DNS server for a domain, or maybe a preloaded resolver that can receive these queries and decode the hidden data.
So normal-looking DNS traffic could actually be smuggling sensitive information out.
It can be, yeah. It's often slow but very stealthy because DNS is usually allowed through firewalls.
Flying under the radar. And attackers also just register domains for bad stuff, right? Malicious registration.
Oh, constantly. That's often step one. They'll buy domains that look very similar to legitimate ones, type of squatting, or just domains that sound generic or relevant to their planned scam or malware campaigns.
Setting up their infrastructure before the attack even starts.
Exactly. They need domains for phishing sites, for malware C2, for sending spam. Registering them is cheap and easy.
And is creating subdomains under dynamic DNS providers similar.
It's related, yeah. Dynamic DNS services are meant for users with changing IP addresses, but attackers abuse them by creating lots, sometimes thousands, of subdomains under these dynamic DNS providers.
Why use those specifically?
It's often free, very fast to set up, and gives them a large pool of disposable domain names for malicious hosting, or C2, often making takedowns harder because there are just so many.
Right, a constant churn of malicious subdomains. Now, you mentioned earlier that it's not always direct DNS manipulation. Sometimes other compromised servers play a role.
Definitely. Think about a phishing attack. The attacker might register a malicious domain, yes, but the phishing page itself, that might be hosted on a completely separate compromised web server.
I see. So the web server compromise enables the DNS-related, the phishing domain.
Exactly. Or a compromised email server could be used to blast out spam containing links to those malicious domains. The different parts of the infrastructure work together. The DNS abuse relies on the compromised server.
Makes sense. It's an ecosystem. Okay, one more technique. DNS beacons for C2 communication. How does that work?
This is another way DNS is used as a covert channel, similar to the exfiltration idea, but more about ongoing command and control.
So the malware regularly phones home.
Yes, using DNS queries. It might send out a specific type of query periodically. If the attacker's C2 server sees that query, it knows the infected machine is online and might even send back instructions encoded in the DNS response.
Again, trying to hide in the noise of normal DNS traffic.
Exactly. It can be very low and slow, just a periodic check-in, making it hard to spot compared to, say, constant HTTP connections.
Okay, that's a lot of different ways DNS can be abused. Now, let's loop back to the framework, specifically the stakeholders. Why is identifying them so important for someone dealing with an incident?
Because the internet, and DNS specifically, isn't run by one entity. You have domain registrars where names are bought. You have registry operators who manage the top-level domains like .com or .org. You have hosting providers, recursive resolver operators like ISPs or public DNS services.
Lots of different organizations.
Tons. And each has different capabilities and responsibilities. If you see malicious domain registrations, you need to talk to the registrar. If it's cache poisoning affecting users of a specific ISP, you talk to the ISP's resolver team. Knowing who to contact is key to getting something done.
You need the right tool, or rather the right contact, for the job. And the framework also lists actions: detect, mitigate, prevent. These sound like standard incident response phases.
They map closely, yes. Detect is about spotting the problem in the first place, monitoring DNS logs, getting abuse reports, noticing anomalies, though confirming it and gathering specific tools often rolls into mitigation.
Okay, so detect is the initial flag, then mitigate is.
Mitigation is stopping the bleeding. It's taking action to contain the attack and get things back to normal. Suspending the malicious domain, cleaning the poison cache, blocking the C2 traffic, the hands-on fixing.
And your prevent, is that just general security?
Within this context, prevent is more DNS specific. It's about learning from the incident to stop it from happening again via DNS. So sharing knowledge about these techniques, maybe tightening your own DNS security posture, updating detection rules based on what you saw, fixing vulnerabilities that were exploited.
Gotcha. Not just general anti-malware, but DNS-focused prevention.
Right. It's about hardening the DNS aspects specifically.
This has been really clarifying. DNS seems so simple on the surface. Type a name, get an address, but the potential for abuse is clearly vast and complex.
It really is. And understanding these techniques, understanding who holds the keys in the ecosystem, that's critical if you're trying to defend against this stuff or respond when things go wrong.
It underlines how interconnected everything is and how security depends on cooperation between all these different stakeholders.
Absolutely. No single group can solve DNS abuse alone. It requires awareness and action across the board.
So maybe the question for you listening is, thinking about this evolving landscape, how do we improve that collaboration? How do we get better collectively at detecting and shutting down this kind of abuse faster? Definitely something to ponder. TechDaily.ai, your source for technical information. This deep dive is sponsored by Stonefly, your trusted solution provider and advisor in enterprise storage, backup disaster recovery, hyper-converged in VMware, Hyper-V, Proxmox cluster, AI servers, and public and private cloud. Check out stonefly.com or email your project requirements to sales@stonefly.com.